This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 188. Glad to see so many of you on today from our Weather Service field offices. The title of today's presentation is Basics of GOES ABI Satellite Interpretation, a classic. I'm glad to have Randy Bowers, lead meteorologist at the National Weather Service Forecast Office in Indianapolis, Indiana, with us. And our facilitator today is Dr. Dan Lindsay, the GOES-R program scientist. So we should have a great discussion following Randy's presentation. Just a few reminders before we get started. As you just heard, this session is being recorded. As always, we have Q&A. Please post your questions in the chat and we will field them in the order they are asked. If you have signed in with an office account, please note your name in the chat and we'll follow up if necessary. We're looking for future presenters, so please contact the Tower S team, Kashad and Emily, if you're willing to help us on the SBC. And the training team can help create training materials that may be unavailable. Ross Van Til can help with that. I'd like to thank our Tower S team, Kashad and Emily, the Office of the Chief Learning Officer, the GOES-R JPSS program, our presenter, facilitator, and all of you for being with us today. Without further ado, let me introduce Randy, who's been a forecaster with 4 different offices in the Plains and Midwest, 11 years of experience, and currently a meteorologist at WFO Indianapolis. Mesoanalysis is his passion, the challenges of finding subtle details in observational data that explain the behavior of the atmosphere and allow us to more accurately communicate what will happen to our core partners is what he enjoys most about the job. And I know many of you from the field share a similar passion. So, Randy, we're glad to have you back with the Satellite Book Club today.
Yeah, thanks, Jordan, and a big thanks to the entire Satellite Book Club team. You guys are great. You always facilitate really good, obviously, talks and good sharing of information and discussion too. So really appreciate that, and thanks for having me today. So yeah, I mean, obviously the first slide is pretty basic. I got a water vapor loop. I'll get into that in just a second, but a couple motivation points I guess to start with is, you know, we've had some really good successes with our partners, and the feedback we've got, especially in recent years, as far as precision and accuracy of what we can do is just amazing now compared to, you know, say 20, 30 years ago. So we want to continue that momentum, obviously, and fulfill the needs of our partners. And we're doing such a good job of that, obviously. But mesoanalysis is something I'm passionate about. It really kind of goes into that. And satellite interpretation is a huge part of mesoanalysis. So, you know, the one thing is I know a lot of forecasters, including myself at times, we sometimes feel like that there's just an overwhelming amount of data, and especially younger in the forecaster's career. So if there's any forecasters out there that have been doing this for 6 months or a year or so, just know that it gets better with time. You start to refine your skills and how you can go to the data and pull out what you need. But a big part of that, and one of the really key things I wanted to talk about today, is just going back to the basics, having that as a good foundation, just visible satellite, water vapor, knowing what you're seeing, the features there, and then from there you start to add some of the newer data sets, the emerging, you know, things such as worn-on forecasts from a storm scale modeling, high-res modeling, and then all the derived products that come from satellite now. Those are things we add to it once we get the fundamentals. So this is a talk really about the fundamentals and doing that diagnosis before prognosis, knowing what the atmosphere is doing now. That really helps going forward, kind of with being able to add all the new elements that we have as far as data sets that can take the forecast the extra mile. So that's really what I'm passionate about, and kind of wanted to highlight that today. So thanks again for the opportunity to do so. This is just a simple water vapor loop, mid-level water vapor. What's interesting about this is you can see the ascent that starts to move into West Texas as the moisture arrives at the same time. So it's basic, but again, you can use that just to time out exactly when this process comes together so that convection develops. And this is from back on the 27th. So this is just a few days ago in the Southeast Texas Panhandle. You can see in the pre-dawn hours, there was some convection that erupted early on. And SBC did a good job of highlighting this, but again, they talked about the water vapor being, you know, and seeing the cirrus that was coming in that was indicating that the ascent was really increasing with the shortwave that was approaching. And that would sort of impinge on this moisture that was returning across West Texas, and you would end up with thunderstorm development before sunrise. And indeed, that's what happened. The models did fairly well in this case, but it's just an extra layer of confidence. The observational data is telling us the same thing. So to refine that timing and bring it down to the most specific we possibly can, this is just a good example to show that. It's not a unique example. You can look across the entire United States and find numerous examples of how satellite can enhance the near-term forecast every day. And this was just a couple days ago. I think this was Tuesday morning, if I remember right. And the advected layer of precipitable water in the 850 to 700 millibar layer, you could see that the moisture was surging northward through the central plains and into the eastern part of Nebraska. And then just overlaying the infrared on that, you can see that thunderstorms developed as the large-scale ascent moved over top of this returning moisture. So it was a similar situation to that example from Texas. This happens so often in the plains this time of year. And so thunderstorms developed in the pre-dawn hours there too. So just a good example. Again, watch the observational data, be able to refine the forecast. It's really important to kind of keep an eye on that. So again, we went over the motivations, but there are things where are we at in 2024 in the National Weather Service? Well, I think most of us would agree that the older method of just looking at 3 or 4 deterministic models and trying to pick one that best suits day 6, that's kind of behind us now. We're moving past that. We have blends, forecast builder, and things that can give us a good first start, and then we can contextualize that. But the process has changed some, so we're not as involved in the extended forecast quite as much as we were in the past. But where we are involved in is looking for these subtle details, the cold pool character. How did the models initialize with that? Do they handle the cold pool well in these summertime convective regimes? But also knowing where the sources of error might be in the high-res models and for warn-on forecast, for example, and then how can we take that information and extrapolate it forward to correct for model errors. But there's a lot more to that, and there are probably several that you can think of too that kind of go along these lines as well. But just the boundary layer moisture characteristics, sometimes you have convection that blows up, subsidence downstream from that changes the forecast last minute. Suddenly you're not dealing with as much convection now downstream because you had such a big blow up of convection upstream. Now, these things are things that we're familiar with as forecasters, but they're really important to kind of to know what to do in those situations. Things as simple as pinpointing mesoscale snow bands for heavy mesoscale snow, and the placement of the models might be off just slightly, and we can refine that forecast based on the observational data and what we see in satellite. And convective initiation that happens in the mid levels of the atmosphere above a capping elevated mixed layer, sometimes that's common in the plains. And it's just good we got an example coming up of that we'll show, but I'm sure you can think of plenty others that are similar, just ways that you can use satellite data and other observational data to kind of get a handle on what's going on. One thing I really like to do, and this is going back to March 31st of last year, pretty big tornado outbreak that happened. And you may not be able to see the state lines very well in the image. Hopefully you can, but if not, Indiana's on the right, Missouri's on the left. So it's kind of centered on Illinois. And the first thing you may notice is just the character of the cumulus field across Indiana really indicates stability. And so further west, that transition is into a more unstable boundary layer, and you can see that the convection kind of orients a little bit more into horizontal convective rolls. Whereas to the east, they're more billows, indicate stability, so they're perpendicular to the shear vector. So you can just tell a lot from looking just at the satellite. You don't have to have a model to tell you that it's a sheared environment and that it's somewhat stable over Indiana. And that's the key. So I'm sure as you look at this right now and you think about what would a sounding look like over Indiana at this time, you probably got a mental image in your head about what it would look like. And so we use an ACAR sounding to show that, yeah, if you thought there was an inversion there to where it's kind of capping convection and that things were fairly stable, you were right. That's what the sounding looked like. The observational data told us that. So it's just nice because a satellite, you can fill in spatially where the sheared and more stable environment is and see those transition zones into where you're still sheared, but you're more unstable. And this is just one of many examples I could show that show the power of just looking at satellite to be able to kind of infer that. And then you can see the horizontal convective rolls that orient more parallel to the low level mean wind across Missouri. And what ended up happening in this case, as you can see, there was some convective initiation in the very bottom left. I don't know if you can see my cursor or not, but there's some glaciation starting to show up in the day cloud phase RGB in southern Missouri. That was the start of a pretty bad evening across portions of Missouri and Illinois and all the way into Indiana. We had an EF3 in Indianapolis that happened that initiated from convection that was over, that basically come from these horizontal convective rolls back to the west. And then the environment rapidly transitioned from more stable to unstable just ahead of those supercells as they begin to move into Indiana. So it's just one example of how you can take the atmosphere in a snapshot And you can use satellite to really understand kind of what's going on, and then fill in the gaps of where you may not have that information with the model data. So I want to go into a couple of other case examples here just to show the power of just the basic fundamental satellite interpretation. And these two cases come from my involvement with the remote mesoanalysis initiative, basically. So kind of working as in the Pittsburgh offices. I don't know if we have anybody on for those offices, but they may remember this event from back on the 14th. And it was just a good example to show that in the satellite loop, and just in the visible satellite, you can see that there's a stable layer that kind of moved off of Lake Erie. And then so the most unstable area was where the cumulus was more vertically developed, south of Erie, Pennsylvania, kind of in the northwest part of Pennsylvania. But there was a delineation between the stable environment and the more unstable environment there for sure. And you could see it just in the cumulus field. More vertically developed cumulus, back to the west, not so much. What was interesting about this case, though, is there was convection that was already ongoing over the lake, all the way from southeast Michigan across Lake Erie. And it was just rooted in the mid-levels, and it was pretty weak. It wasn't impressive on radar at all. So then the question was, okay, we know the environment downstream is more favorable, but when does that transition from elevated weak convection to more surface-based, deeper, stronger convection happen? And the satellite tells you so much there, because again, you've had that corridor that's highlighted in the yellow color that shows that that there is more instability in that area. So that the theory, as meteorologists, we know that the mid-level convection starts to move into that environment. It becomes more surface-based, and that's when the problems start. And that's what happened that evening. And as part of the remote mesoanalysis, the facilitator that preceded me, Andrew Quigley, he kind of highlighted all that and was able to communicate that to the offices. So I don't know. I don't know if you guys have been involved in the past with the RMA, but it's a really good program that sort of is a good opportunity for us to kind of use subject matter experts in mesoanalysis to support the offices. So I just pulled these examples from that, and to dive a little bit deeper into this particular case, you can see this is a pretty short loop. This is 1 minute satellite data, the day cloud phase RGB. And you can see that the character of the storm tops changed markedly when this mid-level weak convection moved over top of that cumulus field that indicated instability. Suddenly now we have overshooting tops. You can tell you've got deeper, more intense convection. And you can see it in the infrared too. As it loops through, you can see the cloud top suddenly get a lot colder. And so it's just one of those things where the satellite data and the observational data can really help you refine that timing and give you confidence to what's about to happen. I mean, we do a model-based forecast, but then to really start to refine that forecast and downscale that to some specific messaging is kind of what we're after with this. So this case progressed on. Obviously, it became pretty intense across Western Pennsylvania, but then it started to weaken. And just as something as simple as looking at the cooling of the cloud tops with the MCS that evolved over central Pennsylvania was enough to give us confidence to be able to message and say, hey, there's a downward trend with the warming cloud tops on IR. So the chances of this wind threat sustaining deeper into central Pennsylvania is probably pretty limited at this point. And it takes, you look at it in multiple data sources, you can see the radar trends, but also knowing the environment. But the satellite really kind of tells a story there, the warming cloud tops. This is kind of a done deal as you get into the Appalachians and central Pennsylvania at that point. So just one use of, we're all familiar with that, but it's just a good example, a good reminder that the fundamentals of basic satellite interpretation can be really helpful. And then the other question that day was, how far west would the convection develop into Ohio? Were we going to be capped enough? And what was interesting is you can see it's not a substantial signal, but you can see the brightness temperature change, and you can get an indication that there's some subsidence in the wake of the shortwave trough across portions of Ohio. And that was sort of lean against much convection developing further along the front. Now, the initial thought was even into our area in Indianapolis, the eastern part of Indiana that day would potentially have some severe weather threat. But as time progressed, it became obvious that this was mainly going to be confined to the eastern part of Ohio, and especially into Pennsylvania. And the observational data helped us understand that. And here's just a little bit more on that. Taking the model soundings, this is a RAP sounding, and you can see it's toggles between the more convectively active regime in Pennsylvania, east of Pittsburgh, and a point that's further west in Ohio. And the difference there is that there's a little more capping, you can see, and a little more dry air in that layer between the LCL and the LFC. So that was a little detrimental to convection. It wasn't going at that point by the time we got to mid to late afternoon. And so at that point, it was kind of a question of would it develop? And I think when you put it in the context of knowing from the satellite perspective and water vapor, that there's an indication of substance. So it's not going to get any better back in Western Ohio and Central Ohio. It's not like we're going to lift out that cap and substantially moisten that critical layer there to get convective initiation. So we knew that. And so what we did was we saw it in the cumulus field, the trends, and then we put out this message that basically said anywhere west of I-77, roughly from Cleveland down to Canton in that area, it's pretty unlikely. Maybe we could get isolated convection developed, but for the most part, the cumulus field and the visible satellite and the trends in the water vapor really pushed us against the earlier forecast that we could have isolated convection. We were thinking now it should be confined to Northeast Ohio and into Pennsylvania. And again, it goes back to just the simple observations, looking at the character of the cumulus field and looking at the trends in water vapor really kind of supported the trend there towards no convection. And what happened later on that evening, there was convection that did build all the way back to Cleveland, but it really didn't go any further west than that for the most part. So it was a success of mesoanalysis, really, just looking at the observational data and the satellite data to make that determination. So I got another case here I was going to go over real quick. It's really interesting. This is in the plains. This was the next day. This is back on April 15th. And what you can see here is the moisture. The dry line is clearly evident. This is the surface to 850 millibar advected layer precipitable water product from Sierra. And it's infrared on top of that. So it's kind of a sandwich between the two. I was playing around with that just to see what that would look like. And what's interesting is this was an event that looked like it could be pretty substantial. And there was anticipation of convective development all day long, and it just didn't happen. For the most part, there was some elevated convection on the northern end of the outlook area, but further south into Kansas and especially down at the southern plains, we just didn't have much as far as severe storms developed during the daylight hours. Later that evening, though, once the trough finally started to kick out, you can see that the indications of that with the ascent move across eastern Colorado and into western Kansas. At that point, that's when things started to come together. So this is where the messaging challenge was, is the timing on that ascent in the Pacific cold front and the lift that would interact and meet with the dry line and the deeper moisture across central parts of Kansas. And so that's kind of the focus area there. So the message that, in hindsight, I probably could have put out a message that was a little bit more deterministic as far as timing, because the satellite data gave us that opportunity to do so. But we still said that there was some uncertainty with the specific timing, but we knew the process that would happen. And that was once the retreating dry line and the moisture sort of interacted with the larger scale ascent from the trough that was moving in, that boom, you would have convection that would initiate. And that's what happened. And what was interesting too then is now really downscaling it to the 1 minute mesosector data of IR of 10.3 micron. You can see that the convection started to develop, and as soon as it did, we crafted a message and just sent it out to the offices, and they were looking at this too. But again, this remote mesoanalysis support, just that dialogue and that conversation that was going on, we were able to say, hey, the first signs of convection with the onset of basically where the front was merging with the dry line, we were starting to see indications of that. What was interesting is even before the radar really showed much at all, we were starting to see the enhancement of the cloud tops in IR. We were able to jump on that saying, hey, it's go time. This is basically where we're at with it now. We've got this convective initiation. So from here on out, we're going to be looking at a severe weather threat downstream. And then you can see what happened. This continued to develop, and with time, you start to see the GLM, some lightning strikes that started to occur within the line of thunderstorms that started to develop there. So it's just the timing and the spatial characteristics of it, just refining that, constantly going from your model-based forecast to just downscale and downscale, downscale until you can really provide as much precision and accuracy as you can with timing and threat magnitude is kind of really what we're after here. So, and then the other aspect of this case too that was really interesting was later in the night, we still had a really good parameter space. In fact, the low-level jet ramped up pretty substantially to where the photographs were really favorable for tornadoes. There was, the elevated mixed layer was still in place, so there were some factors working against it. So the question was then, now we're starting to see convective initiation over Oklahoma that's moving up into central Kansas. What does that mean? Are we going to be dealing with tornadoes? Is this going to be as high end of a threat as it could have been earlier in the day? Well, there were some things that kind of pointed against that a little bit. And one was just if you look at just the character of the way the water vapor and the brightness temperatures are, you can tell that the trough is starting to have some impact on the atmosphere at that point, that there's some ascent going on. And so the convection that was developing in that area, once we paired that information with the model soundings and saw that we were moistening up pretty good in the mid-levels, but this is all occurring above the capping elevated mix layer. So the message in going back and forth with the Wichita office was that this is probably mostly just convection rooted in the mid-levels, and that the chances of it being more surface-based were in question, but it seemed like that the immediate threat for tornadoes and higher end severe weather was probably pretty limited, because this is probably mostly just a more junky convection that's rooted in the mid-levels, just based on the entire process of what we're seeing, using satellite as a foundation for that analysis. That's kind of what led us to that conclusion. And indeed, I think there were some, obviously up in Hastings area with the line, they had some tornadoes, and I think later in the night there was a little bit more substantial severe weather up into maybe, I think it was Topeka's area and over towards Omaha's area. But for the most part, that we were able to say, okay, well, there's limited chance now for the higher end worst case scenario across central Kansas. And I think the observational data was a big part of what allowed us to say that. And then this is just one case from a while back that Ted Ryan, the former SU at Fort Worth, had passed along, and I thought it was interesting. This is simple. There's no big convective outlook, no anticipation of really high impact weather. But what's interesting is there's a little bit of an enhancement of the cumulus across the DFW area here. And there's a outflow that's moving northwest. So if you put the two together, the little band of cumulus that's over the Dallas-Fort Worth area kind of tells the story a little bit there, that there's something going on with the atmosphere. A little bit more moisture in the boundary layer. There's something there that you can now cast and say, this is just an example of how this may play out, that you can highlight an area saying that within the next 2 hours, there's some chance of isolated to scattered thunderstorms based on the trends in the observational data. It's simple. This is something that us as National Weather Service forecasters do routinely, but it is good to kind of review just to say that the fundamentals from a satellite interpretation and observational analysis can lead us down a road to where we can give that precision in the next 2 hours to say that maybe not so much in Terrell, maybe not west of Fort Worth as much, but yeah, that area from the east side of Fort Worth across Dallas in the next 2 hours as this lift from this outflow boundary comes in is probably going to be enough to where we see some thunderstorm development there. And so it's just, it's just an example of how just that continuous monitoring of the satellite data is so critically important to refine the near-term forecast. And I just wanted to, again, talk a little bit more about the remote mesoanalysis initiative. And these are just a couple examples from several of the facilitators. I'm just going to thumb through these really quick just to show, for those that aren't as familiar, that don't keep track of this as often, there's a lot of satellite data that's used in here. Matter of fact, satellite, I would say, is one of the, obviously the foundation for the analysis that the RMA facilitators are using. And there's so many good examples of this. I can just go on and on about how much satellite's so important in the analysis there. And so it's just a good example to show how we're leveraging that, how we're changing our operational model, the way we operate in the Weather Service to leverage our talent across the agency, to share in the workload a little bit. And it's just a good example of that, with RMA being one of the ways that we're doing that. But again, the mesoanalysis really needs to happen at the local level, and it can be supported from this RMA program, but it's just something that's fundamental to our operations in the Weather Service going forward to really serve the partners the best we possibly can. And just a few final points here, really just talking about mesoanalysis. I tried to condense it as much as I could, at least these are my views, is that the mesoanalysis is where we as forecasters can take the forecast that final mile. And we can make big gains and we can refine that accuracy, the timing, and the threat magnitude. And satellite is a critical role in the mesoanalysis process to make that happen. And that when we pair that with all these new things coming, we're talking about a lot of machine learning innovations, AI, derived products in satellite, high-res models, worn-on forecast, then it becomes a very powerful combination when you have that foundational satellite analysis that you can pair with all these new tools. And we can just do some amazing stuff going forward. And so some action items, I would say, really emphasize that mesoanalysis and really encourage subject matter expertise among your forecast staff and satellite interpretation to never stop, just continuously build that skill as best we can. And look for examples across the country that are ongoing. And it's really a good way to continue to build that skill. And Jordan, that's really all I have at this point. And Dan, I know you're helping facilitate, but I'd take any questions at this point and hopefully have a really good discussion. And I appreciate the time.
All right. Thanks so much, Randy. That was tremendous. I share your love of mesoanalysis. I think, you know, we see all these features on satellite that many of them you showed, and the grand majority of that information is not making its way into the models. The data assimilation techniques just aren't good enough to take what we can see with our eyes and our, you know, infer with our brains and get that into the models. So I think this is a critical skill, and I really appreciate you and many others who are out there pushing it and doing sessions like this to train other folks how to take best advantage of that satellite feed. So we're going to shift in just a moment into our Q&A period. I encourage everyone who wants to ask a question to either, you can put the question in the chat, or you can just say in the chat that you want to be unmuted and ask it verbally, and we can do that too. I would particularly like to encourage those from field offices and the regional headquarters to ask questions. And if you do that, please do specify your full name in the chat when you're asking the question. Before we start that, I would like to advertise that next week on Thursday, May 9th at noon Eastern, Bill Line, who has presented many times before from NESDA STAR, will discuss satellite applications for severe convective forecasting. And additionally, please contact Tower S team, specifically Kashad Bowman or Emily Maddox, for questions about the Satellite Book Club or for configuration of satellite products in your AWIPs. So now I will switch over to the chat, and I know there has been a few comments and questions, and I'll kind of go to the top. So let's see, we have a comment from V. Wegman. They were in Beaver Falls and Pittsburgh during the storm. I think this was maybe your first case, or maybe it was the one that went through Pennsylvania. It was a memorable one, part of a long weekend of severe weather. And I'll just pause this if you want to respond to that at all, Randy.
Yeah, I'll just make one comment on that, that it really evolved. And what was interesting is working with the Pittsburgh office on that, is it evolved into a kind of a local mesoscale, not a high-end flash flood event, but that just suddenly things with the Corfidi vectors all kind of come together in such a way to where that ended up being a little bit of a transition towards a concern for flash flooding, especially with antecedent conditions there. So it's interesting because you go into it with a severe weather mindset, and then suddenly now, oh, well, now we got to deal with a flash flood situation because of the way the convection is evolving. And so that was an interesting aspect of that event.
Thanks. Next comment is from Steve Corfidi. The transverse banded high-level cloud system in eastern Colorado on the evening of April 15th is a good example of what's been referred to as a delta cloud, indicative of strong upper-level divergence. I actually have never heard that terminology before. So I don't know, Randy, do you want to reply? And maybe Steve can say a little bit more about what that is if you'd like to come off mute.
Yeah, I'd just like to say I haven't heard of it either. You know, and this is why these sessions are so important, to have this kind of discussion and conversation. And yeah, if not now, in the future, I'd definitely love to hear what Steve has to say about that, because that's really, I think that's good information.
Yeah, Randy, it's a great presentation you just did, and I do remember that event. Yeah, I think it was an Australian author or group of authors, but you know, that the concept of a delta cloud goes back, I think, even into the late 70s and 80s, when the you know, the resolution of the GOES imagery was not as good as we have today. But basically, it's a delta or triangular shaped cloud field, cloud system that primarily, I think, is in the upper mid levels and into the higher levels. So it's a lot of times it's cirriform or cirrus type clouds or alto cumulus. But it takes the pattern of a delta, and it is associated. And there was another example actually here in more recent days. I don't remember exactly which day it was, but it's triangular shape and marks the exit region, ageostrophic circulation, where the strong, you know, ageostrophic component of the wind field is at work and helps create clouds in the exit region of a strong jet streak. So where there's a long stream variation of the flow. So you have the jet streak upstream, and you get the divergence going on in the exit region. So over eastern Colorado on the evening of the 15th, that case you showed, I remember commenting just to myself, or I think my wife was actually going by, Sarah Corfidi was going by, and I said, look at that very good indication that, you know, the forcing for ascent is definitely in place, although it was still back over the dry air in that case, and this more recent one that I remember. But it going along with what you were talking about, satellite is providing free up to the minute indication of what the real world is doing. And I think you conveyed that you can do a lot of value added interpretation of what the real atmosphere is doing. And when you see those kind of clues in that case there on the 14th and the 15th over the high plains was certainly one of those where if there was any doubt about the strength of the forcing for ascent at mid and upper levels, that cloud feature certainly was lending credence to the idea of whatever model chosen or ensemble output that you wanted to look at, seeing those transverse bands over eastern Colorado was telling you that the jet streak was definitely starting to have its effect in the dry air. And once that forcing for ascent got farther east, you certainly were going to see some response given the sounding that were in place, the ingredients that were in place in the lower levels. So anyway, good job. And yeah, that it was a weather and forecasting paper, but like I said, it even goes back, I think, the term farther back in time than just that paper by the Australian authors who were using it to anticipate the arrival of forcing for ascent, from the west in Australia.
Yeah, thanks a lot for that, Steve. And that sounds like a good satellite book club topic in itself, actually. Maybe something to consider for the future. Let's see, Bill has a question. Are there any technical aspects related to viewing satellite information in AWIPS that you wish could be improved?
Yeah, thanks, Steve. And Kashad too. I think that was the case 3 was where that delta signature was. I see you have control there, so if you want to show that. But anyway, yeah, Bill, that's interesting. I would personally, what I end up doing sometimes, I think, is because AWIPS at times can be a little bit overloaded and slow, is just to get a basic overview of water vapor. Sometimes I'll take, I'll just go to college at a page and then kind of look at just do where you can skip several frames so you can go back and do a long loop. So I think if we had that functionality in AWIPS to where, first of all, it was just a little bit more capable of taking in a lot of satellite data at one time, or displaying a lot of satellite data at one time without having some of the technical issues. And this is a big wish list, I know, but this is just me personally speaking. And then maybe being able to skip several frames so that you can do a longer water vapor loop that's quicker over a longer period of time, I think would be helpful. Those are just the first couple things I can think of off the top of my head. But some of the ways you can pair data and overlay and mesh it together is pretty incredible on AWIPS. But yeah, just those 2 requests I think are the first that pop into my mind.
Yeah, my impression on talking to various forecasters is some offices have more issues than others with regard to things like memory and bandwidth and stuff like that. And maybe that plays into sort of more local issues in some AWIPS in some places more than others. But I can't really speak to it because I'm not a forecaster. Let's see, Chris Smith has a question regarding a product which I don't know everyone knows about, so this will be a good chance to ask, but have you used a product called ProxyViz to track features at night, such as outflow boundaries?
I've never heard of it. I feel like I probably should have heard of it, but I haven't, and I'd love to learn more about it for sure.
Yeah, this is a good, I guess, a note to Tower S. Maybe we could have Galena or someone come on and talk about ProxyViz, or maybe Chris, because this was a product that basically tries to mimic what just a regular visible band would look like during the day, during 24 hours. So basically it goes from day to night and still has sort of the black and white and attempts to highlight low clouds, developed by Galena Cherikova at Sierra. And I know it's running it was developed originally for the Hurricane Center. So I know it's running there and in some of the national centers, but I'm not sure if it's made its way to AWIPS yet. So that's a possible future topic for this venue, I think. Let's see, Sarah posted a link asking if that was the link for the paper referred to by Steve. I haven't scrolled down, but is that in fact the paper you were talking about, Steve?
Yes, it is, and I just sent her a thanks. I appreciate that. We're not in the same side by side here, so yeah, that is it. Thank you.
Okay, yeah, thank you for that. That's a good reference for everybody. Okay, Tim, question. Do you think you're missing any vertical moisture and temperature info? If so, would clear sky satellite retrievals on fine temporal and space, say 4 kilometer spatial about every 30 minutes help? I know this is a loaded question, but I'll let Randy ask or answer, excuse me.
Oh, I would take it for sure. You know, I think one of the most successful, or one of the default products for me, and you know, my coworkers in Indianapolis and then the Fairbanks team that I've been kind of working with a little bit too, they'll say that I always talk about the vector layer precipitable water, and the fact that it can layer things out to where you get retrievals and you get information about low and mid-level water vapor instead of just the mid and high level water vapor that we were used to seeing them in just the traditional water vapor bands is really, I think it's really tremendously useful. So if this can be done on a, you know, even finer scale, I think would be really, really helpful.
Just a quick follow-up to that. Several of your slides you showed some soundings. Were those, what was the source of those? Were those actually model soundings, or were they actually radiosondes?
The one was a radiosonde, the one that was the Indianapolis example, and it was, well, it wasn't a radiosonde, it was an ACAR sounding.
Okay.
From aircraft, and then the rest of them were model soundings basically, and trying to make the point of, you know, hey, this is what we're looking at from a model standpoint, and then we're trying to make sense of that based on the observational data.
Do you guys get those aircraft soundings in AWIPS?
No, we don't. And I think it's Derek in Tulsa had really helped out with that. Derek Hodges in Tulsa had really helped us out with a site that we can go to view those data, but no, we don't get them in AWIPS, unfortunately.
Gotcha. Yeah. So Tim's message, what he's referring to almost certainly is something to get you excited for the future. The GeoXO series will be the follow-on series to the GOES-R series, launching in the 2030s. And as part of that will be an infrared sounder, hyperspectral infrared sounder, operating from a center spacecraft in the middle of the country. And what that'll do is potentially give us up to 30-minute refresh with very fine spatial scales of these types of retrievals. So you won't have to rely on models, and presumably you'll get some actually real-time information about things like, you know, the instability in the cap and things like that. So something to look forward to in the future. Let's see. There was,
that's super good to know, because even two of the examples I had really kind of play to that a little bit. You know, what was going on across Ohio on the 14th, central Ohio, and just knowing, you know, is that dry layer in the models? What does that actually look like from an observational standpoint? And then also the case of the convection that's starting to initiate overnight on the 15th across the central plains, and just trying to infer what we could from mid-level water vapor. But yeah, to have that kind of data would be just amazing. I'm looking forward to that.
Yeah, that's great to hear. I know there was a session a few weeks ago with Tim Schmidt and Frank Alsheimer where they talked about that sounder in the future. And so maybe we'll do another one again to catch people who may not have been here for that one. Oh my gosh, we got a lot of good questions. I need to move quickly here. So there was a question about proxy viz that I think we already answered, but we'll put that on the future list of satellite book clubs. Sarah comments, we use the College of DuPage site all the time, so we can get the water vapor satellite loops for the past 2 to 3 days. That is a good site. I've used that before. Becca comments that proxy viz is great, and they do have the product up in Alaska, so that's good to hear, Becca, which means it should be available in AWIPS somehow, so we can work on getting that to more users. Chris says he can include some proxy viz talk in his, he's doing a satellite book club talk in June. And also, if you go to the Satellite Liaison blog, if you just Google Satellite Liaison blog, you can find it. And he actually provides a link there. I'm reading down sequentially here. Let's see. And it is running in AWIPS at the OPC. That's good to know. Okay, Lee says, okay, yeah, so that's right. Galena has presented at Satellite Book Club in the past on proxy viz. And it looks like Lee's going to post the link momentarily if he hasn't already. An online source for proxy viz. So I think the Cirrus slider has the proxy viz. If you scroll down, I can check that for sure. Oh, it says no additional information available. Okay, I'll have to follow up. I'm behind on the chat, I'm sorry. Okay, John Forsyth. He says his latest info from NESDIS is that the ALPW should become operational in the July to August 2024 timeframe. It's being migrated to the cloud. So that's good to know for the advected layer precipitable water. Sorry, Randy, I'm saying everything because nobody's really asking many questions here. Let's see, Michael Boland, you can use the time options tool under options and AWIPs to make longer loops skipping frames. It's a little particular and clunky, but it can be set in a perspective or procedure. So that's a possible solution to something you mentioned, I think, Randy.
Okay, yeah, I need to check that out. Yeah, that's really good. I'm learning a lot with this. This is really good stuff. I'm pretty excited too with all the new stuff coming, and that's excellent.
Yep. Oh, and then here we go. Oh, there's a paper on proxy viz. Thank you, Adrian, for posting the link to the paper, which talks about sort of how it's done, some of the applications. Chris answered the questions. Carl, regarding ALP. Carl, this is kind of long. Do you want to come off mute and ask this verbally?
Yeah, can you hear me?
Yes.
All right. It's not so much, I guess, a question for the presenter, but it was maybe kind of coming off of the conversation about the advected layer precipitable water, becoming potentially like finer in scale, spatial. And I wonder if there was any concerns of, using the numerical weather prediction model guidance to help drive those hourly movements of the layered moisture data, and kind of with that knowledge to kind of help interpolate between the polar orbiting sample rates. I think it's a great tool for synoptic scale diagnostics, but if we're like really starting to get finer scale in terms of spatial data, I wonder if there's any concerns that we could succumb to model guidance, maybe misguiding mesoanalysis at times. I don't know if the GeoXO sounder will help in this, potentially just getting more moisture data at a faster cadence, but that's kind of it was more of a comment, I guess.
Hey, Carl, I've had that same thought. This is one of those things I'll lay awake at night thinking about. Well, as much as I love advected layer precipitable water, I know it's got that element to it where it advects it. But to me, it's like I've seen more errors in model data from the moisture than I have from its wind field. And so it's like the lesser of the two evils, I guess. At least that's just from a forecaster's perspective, is that I'm getting so much better moisture data than potentially what I get in certain scenarios of the models, that I'll take a little bit of a potential that the models could be misleading on where that moisture is advected to, because for the most part, it seems like it's been pretty accurate from what I've seen, but I'd be curious on what other people think on that.
Yeah, thanks a lot, Carl. And yes, on GeoXO sounder, Carl, that's exactly what it's designed for. So we're excited about that in the mid 2030s. Last question. I know we're out of time, but this should be a quickie. I really like that RMA that you showed near the end, where you're sort of getting real-time people commenting on satellite type features and other things. How do Weather Service folks get involved in that if they're not already looped in, Randy?
I would say work through your SU first, because they'll be in connection with regional headquarters that this really facilitate a lot of this. I know it started in the central region and it spread to eastern regions involved, and to a certain extent southern region has now. But it's been really good, because what it is it's essentially the wisdom of the crowds. It's experts doing analysis on blue sky days in Amarillo or Lubbock to help out, with offices that may be in the east that are just so busy with their duties. So I would say start with your SU and kind of work it up and just inquire about it. And I think it's a program that's expanding with time, and it's been really good.
All right, Tim has one more FYI on GXS, which is the future sounder, and I'm going to pass it now back to Jordan. Thanks again, Randy, for an excellent presentation. Go ahead, Jordan.
Yeah, thank you so much, Randy, and thank you so much, Dan, for facilitating that great discussion. Really appreciate everybody's engagement in that. We are going to continue with our Satellite Book Club Seminar Series next week. Bill Line is going to be joining us to talk about satellite applications for severe convective forecasting. So continuing on this theme, Bill, of course, is the Imagery Science Team lead from NESDA STAR. And again, that will be on May 9th at 12 noon Eastern time. In the meantime, I encourage everyone to contact the Tower S team if you have any questions about the Satellite Book Club or the configuration of satellite products. Kajad Bowman and Emily Maddox are happy to help with that. You can also get a hold of us through the Slack channel on the NWS internal Slack workspace. With that, we'll wrap it up for today. Hope everybody's spring is off to a good start. And thanks to all those out there in the field that are working extra shifts with the severe thunderstorms that are becoming all too common in this season. Until next week, folks, take care. Thank you so much.